and welcome to Rocket Lab's Don't Look Back mission. Thanks to the viewers joining us as we get ready to go to space once again today. Currently we're watching the weather and it's looking good for our launch today. Today's payload will be the Galey 5B. This satellite will observe the Earth's ozone layer and to observe ocean pollution and sea levels. Remember, we are not affiliated with the real-life Rocket Lab. We are a company on Roblox, expanding off of their idea. We do not monetize our work in any way either. Should copyright holders request to take down all Rocket Lab assets, we will do so immediately. We will take down any assets or any videos regarding the group. But now, let's talk about the rocket taking this payload today into orbit. So, today's rocket will be the Electron. The Electron has 2 stages, and the max payload is 225 kilograms, and the nominal payload is 150 kilograms. The height is 17 meters, and the diameter is 1.2 meters. And the nominal sun-synchronous orbit is 500 kilometers. So let's talk about the Rutherford Engine. The oxygen kerosene pump-fed engine specifically designed in-house for Electron. Its unique high-performance electric propellant pumps reduce mass and replace hardware with software. The Electron uses an entirely new propulsion cycle as well. And the Electron's first stage is powered by 9 Rutherford engines, which has a liftoff thrust of 34,500 pounds, which is 162 kilonewtons, and 192 kilonewtons. And the peak thrust is 192 kilonewtons, which is 41,500 pounds. And currently it is T-minus 12 minutes and 20 seconds to the launch of Electron. So let's continue talking about the 3D printing capabilities of Rutherford. Rutherford is the first oxygen kerosene engine to use 3D printing for all primary components. The engine print time is only 24 hours for these. So let's talk about the second stage. So once we've used all the fuel on the first stage, we'll jettison that and we'll start using the second stage. Electron's second stage is powered by a variant of the Rutherford Engine, providing improved performance in vacuum conditions. The total thrust is 22 kilonewtons, which is 500 pounds. Electron makes use of advanced carbon composite materials for a strong and lightweight flight structure. Through an extensive research program, Rocket Lab has developed carbon composite tanks that are compatible with liquid oxygen, providing impressive weight savings. And currently it is now T-minus 9 minutes and 15 seconds. And at T-minus 10 minutes, we had the clamp arm and strong backward tract, and we are now starting with the prop load. So that is our liquid oxygen and RP1 and LOX fuel into the Electron. And you can see since we chill the liquid oxygen, the vapor coming off in the condensate. So that's all nominal, and currently we are good. And so far we are looking good. So now, continuing talking about electrons, so let's talk about the avionics. Rocket Lab excels at producing high-performance miniature avionics and flight computer systems. The computing nodes make use of state-of-the-art FPGA architecture, allowing massive customization of function while retaining hardware commonality. And if needed, an optional apogee kick stage that can execute multiple burns to place numerous payloads into different circularized orbits is available. It opens up significantly more orbital options, particularly for rideshare customers that have traditionally been limited to primary payloads designated to orbit. Powered by Rocket Lab's 3D printed liquid propellant Curie engine capable of 120 newtons of thrust and multiple burns. And as we said earlier, the second stage is powered by a variant of the Rutherford engine, providing improved performance in a vacuum condition. The total thrust is 5,000 pounds, which is 22 kilonewtons. So that's all about the Electron. So let's talk about the fairing real quick. Electron's payload fairing is designed to decouple payload integration from the main assembly. The all-carbon composite payload fairing is designed and manufactured in-house at Rocket Lab's headquarters in Long Beach. So that's everything that you need to know about the Electron rocket. And we're now T-minus 7 minutes and 10 seconds. for the launch of Electron. Currently, all is looking good. We've started our propellant load, and we're standing by for the propellant load to stop, which means we've fueled up the entire rocket's first stage and second stage. And now T-minus 6 minutes and 45 seconds. Currently for this mission, we'll be using LC-1 at the Mahia Peninsula. And currently here in Mahia Peninsula, it is 6:23 a.m. at this time. And it is currently 6:23 a.m. and currently all is looking good. It's a very early morning today, but all is looking good. Pipe thrusters and other systems are go for launch at this time. Currently, we have many things in control this launch, but sadly, the weather is not one of them. So we're still watching the weather for today's launch. So far, so good, but we're still watching it very closely. And currently, we're just getting word now that the weather is go, but we are still standing by. We'll be getting weather checks every 2 minutes once we get to the T-minus 5 minute mark. The 9 Rutherford engines and vacuum engine are go for launch at this time. And final ground checks has completed, and everyone's now taking the launch safety is now in effect, so everyone's evacuating away from the pad for safety precautions. Currently, final ground checks have been done with the satellites around half a mile away, and all is looking good. T-minus 5 minutes and 10 seconds to launch. And ground teams are now moving to launch safety. We do launch safety only because it's for the safety of our ground teams and etc. And because the pilot is on board. That's why we do this, as it's just a safety precaution and it just helps. So, currently we're at T-minus 4 minutes and 45 seconds. Currently all is looking good still. So the next major event will be at T-minus 10 seconds when the water deluge system is activated, and then at T-minus 0 the rocket will ignite its 9 Rutherford engines, and those Rutherford engines will burst to life, pushing the rocket away from the pad. At the T-minus 30 second area, we'll be going from ground power on the rocket to internal power. So once at T-plus 30 seconds, the ground teams will move in for inspection on the pad to make sure there was no anomalies to the pad. And currently the rocket is on internal power. And all the communication satellites are go at this time. All the teams at the communication satellite report that they have good ground links with the vehicle at this time, which is very good. So all is nominal on that side. And we're at T-minus 3 minutes and 10 seconds at this time. Now if you were just tuning in, this is the Electron Don't Look Back mission for Rocket Lab. And the payload for today will be the Galey 5B, and this satellite will observe the Earth's ozone layer and will observe ocean pollution at sea levels. Currently T-minus 2 minutes and 35 seconds. All is still looking good. T-minus 2 minutes and 10 seconds. And just so everyone knows, there is a slight delay on the stream to the real-life mission control center countdown. Just so everyone knows, because of ping delay and etc. Minus 1 minute to launch. T-minus 50 seconds. All is still looking good. We're all is nominal. And we're now 40 seconds. We're fully on internal power at this time. T-minus 30 seconds. All is still looking good. We're currently go for launch. The large dilute system is active. T-minus 20 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. We have commit. 9 Rutherford engines have started. And Electron is off the pad. We've cleared the tower. Go Electron. Electron has cleared the tower at this time and all is looking good. 9 Rutherford engines have ignited and burst into life, and we've cleared the tower, and we're going to space. All the thrust that is required to go by the 9 Rutherford engines for a nominal flight is being delivered at this time, so we're currently go on those 9 Rutherford engines. Currently, the flight dynamics obviously report that the trajectory of the vehicle is good, and we're now pitching downrange. And all is looking good at this time. And the vehicle is still pitching downrange, all is looking good. The next big major event will be main engine cutoff. T plus 1 minute at this time. Currently right now, we're at the maximum aerodynamic pressure stage, which we call max Q. This is the most amount of stress put onto the vehicle in flight. Currently, next major event will be MECO, as I said earlier. MECO will be the shutdown, actually, of the 9 Rutherford engines, and we have MECO. And we're now standing by for the staging event, which will stage the booster away from the second stage. And we're standing by for staging. And we have staging. Standing by for the vacuum engine ignition to push the vehicle into orbit. And we have vacuum engine ignition. And the thrust is building up on that vacuum engine, so that's perfectly nominal. Shortly, you will be able to see the rocket, the Electron first stage, come back down and land in the water near the coast of the peninsula. And the first stage is out of sight, and we have fairing separation exposing the payload, the Galey 5B. The Galey 5B is now exposed. we have fairing separation at this time, and we're standing by for a good nominal orbital insertion burn. And we're standing by for the second engine cutoff, and when we have the payload deployment. Once the payload is deployed, it will be deploying its solar arrays and turning on all of its critical functions to keep ground link. And we have second engine cutoff at this time. We're standing by for the payload separation from the Rocket Lab second stage, or from the Electron second stage. And we have second engine ignition. So currently this is because we are now doing our orbital insertion burn, and we're doing the correct orbital insertion burn, which is what the customer wants. And we have second engine shutdown once more. So we have a nominal orbital insertion burn, and the payload separation has been confirmed. And at this time we have good ground links. The payload solar arrays have been deployed as well, and all the antennas and dishes are now going to be deployed or activated soon. And all is looking good. We have great communications with that payload at this time, and currently the customer has good communications with it as well. And thank you everyone for joining us today as we went into space once again on our Don't Look Back mission. Everything went just as planned, and the Rocket Lab Electron delivered as perfectly and just as planned. The payload has been separated from the second stage, and all is looking good. We'd like to thank everyone who joined us today for watching this mission, and just do bear in mind, remember, we are not affiliated with the Real Life Rocket Lab. We are a company expanding on Roblox, expanding off of their idea. We do not monetize the work in any way either. Should copyright holders request to take down all Rocket Lab assets, we will do so immediately. We will take down any assets or any videos regarding the group. So that is that, and we thank you for joining today's mission. We'll see you on the next one.
Hello everyone, it's Robbie, the channel this is. I'd like to say thank you all for watching the stream today. We had high numbers today, I had 20 views at the max point. So yeah, we will be doing more streams hopefully soon. Now we've got this new stream format all set up perfectly. And yeah, thank you for joining.